Hi, this is notes on 6.2 regular chem, which is going to be about concentration. So we can talk about things being concentrated or dilute. And just to remind you, a solute, you might want to write this in your notes again if you're not sure. But a solute is, what does get dissolved. The solvent is the thing that does the dissolving. So most of the time, water is the solvent. And in chemistry, the solute a lot of times is some kind of ionic compound like a salt. So the difference, sometimes we talk about just being concentrated, which means it has a lot of solute and not much solvent, or dilute, which means it has a small amount of solute with a large amount of solvent. So concentration is going to describe how much solute you have actually in a given amount of solvent. And we're going to make this quantitative now, mathematical. So one way we can do this, and you have this equation on your orange help sheet, is we can calculate the percent weight to volume, which is the mass of the solute, what gets dissolved, divided by the volume of the solution, the whole solution, in milliliters, and then you multiply it by 100, and that makes it into percent. So here's one example of just doing a pretty straightforward problem with this equation. So when you read the question, it's really important that you know kind of what you're looking at and which equation you're going to use, because eventually it can get a little confusing. But when I read this question, I can see that I have 12 grams of sugar. That's my solute, so that's going to go right here. And then I'm going to make 150 milliliters of a solution, so that'll be my volume down here. And then I'm just going to plug it in, multiply by 100. So when I do this problem, I would suggest that you just start plugging in what you do know. So in this problem, we're trying to solve for the percent weight to volume, and then we're going to put our 12 grams of solute on the top, our 150 milliliters on the bottom, and then multiply by 100. So the math here is fairly simple. When you divide, you're going to take 12 divided by 150 times 100, and you're going to get 8. And then with sig figs, it'll be 8.0. And then you don't want to forget the percent. And some people put the percent weight volume to know kind of what percent they solve for. So, we are doing sig figs again. So we have 2 sigs here, 2 significant figures here. That 0 doesn't count unless there's a decimal. And then this really doesn't have sigs. So in a way, it has infinite significant figures. So that's how you would do that problem. And let me show you another type. So this problem, we're going to use the same equation, but again, it's really helpful if you could even write down your given information. I like to sometimes just highlight it. So I have 200 mils of a solution, so that's going to go down here. And now I know that it's a 15% weight to volume, so that's really, I'm being given this. And then they're asking me in the question, what is the mass of sugar? So that is my X right there. So let's try to do the math together. So when I plug into this equation, I would start with 15% here equals X, which is going to be grams of sugar, over 200 milliliters times 100. So when I do these problems, right away, I kind of extend this and I get rid of the 100. So if I divide both sides by 100, I end up with 0.15 equals X over 200 point. And then you can solve however it works for you. I like to cross multiply, so I do this. So then I know X is really just going to equal 0.15 times 200. And then I'm solving for mass, so when I do that, I end up with 30.2 sig figs because there were 3 and 2, and I can have the least amount when I multiply and divide. And then I solved for mass, so it's going to be grams. So I just wanted to remind you guys about moles. We're going to be visiting moles again. So 1 mole of a substance is, if you remember, equal to 6.02 10 to the 23rd molecules. Remember, that's Avogadro's number. And then 1 mole of any substance has a certain mass in grams, which is called the molar mass. And the molar mass, if you remember how to calculate those, like if I was going to do water, I just list the number of each element. I look on the periodic table for the atomic mass, and then I add them up. So 1 mole of water has a mass of 18.02 grams. So this is just to remind you kind of how to do those calculations with moles and molar mass. This question's asking for moles, so we're going to end here, and we're starting with grams. And then you can see, and you guys want to have your pink mole map out. And you should have this filled in that, you put the molar mass up on top in grams over 1 mole. So first thing you want to do is always start with that beginning number that they give you over 1. And then we're going to multiply by, it's not cross multiplication, just multiply by a conversion factor. And sodium chloride, sodium's mass is 22.99. Chlorine is 35.45. So we get a mass of 58.44 grams per mole. There's that many grams of sodium chloride in 1 mole. So I'm going to put the 58.44 grams down here of sodium chloride so that it cancels with this. And then 1 mole of sodium chloride up here. So I can cancel my unit. And then what I'm doing on my calculator is I'm just taking 25.5 times 1 divided by 58.44. And when I do the sig figs here, this doesn't have sig figs. It really has infinite because it's not a measurement. So I have 3 here. I want to end with 3. So I get 0.436. Those are my 3 sigs moles of sodium chloride. So now this is something new now, but related to moles, called molarity. Molarity is a way to calculate concentration. We used a lot in chemistry. So your equation is on your orange sheet. It's the moles of solute instead of grams like it was in the percent weight volumes problem, and then divided by the volume of the solution. So in that way, it's similar to the percent weight volume, except for the unit here is liters. And then you need to realize that in the questions, sometimes I'll ask you for grams. You can easily use molar mass to go between these. So what I mean is, we've got this mole map and we can go between these two easily, but then, you plug in your moles over the volume to get molarity. So let me show you another type of problem. So here's a question. If we have 12 grams of sodium chloride, that's our solute, and we're going to make 150 milliliters of a solution. They want to know what the molarity is. So in this question, I'm going to use this equation, but I don't know moles. So my first step is I've got my grams here, the 12 grams, and I need to go to moles. So similar to what we just did in the previous problem, I'm going to take the 12 grams of sodium chloride. And I know from the previous problem, the molar mass is 58.44. And then that's how many grams are in 1 mole of sodium chloride. And then I'll calculate this, and I'm going to hold this in my calculator. If you do want to round it, you can, but we aren't really going to do the significant figures till the end. So I know my moles now, and now I need my volume, which I have right here, but it's not in liters. So a lot of you can just see that I'm going to move the decimal for that. And you don't have to show your work, but if you're confused at all, I would do what I'm going to do right now. So we know that there are 1,000 milliliters in 1 liter. And then that means I'm taking 150 divided by 1,000, which moves the decimal 3 to the left. So now I have the two numbers that I need to plug in. So now I'm ready to solve for molarity. So I'm going to put my 0.436, whatever was in my calculator, over the 0.150 liters. And when I do that, I don't have the answer, so hold on. Okay, I actually found an error. I was kind of using my, the previous problem. So this, everything's right except for the answer, which will change this down here. So when I do 12 divided by 58.44, I get 0.205, and then it goes on moles. So I'm going to put that number in my calculator, divided by 0.150. And then when I do this, I'm going to go back to my original question. I have 12, which has two significant figures, and 150, which has two significant figures. So my answer is going to have two. So it's going to be 1.4. And then the unit is moles per liter. You can leave it like that. Or mole per liter is the same as writing big M. But be very clear that it's a capital.